Hey everyone, welcome to Unit 6.1 video lesson. Today we are talking about our exponent rules. Okay, so exponent rules apply to something called monomials, which are single expressions that can be a number, a variable, bunch of variables multiplied together, or numbers and variables multiplied together. Okay, the key here is that we use multiplication. So 3x, 2sy cubed, m to the fourth n cubed. Those are all examples of monomials. Okay, there are a couple rules that apply in order for something to be considered a monomial. So first things first, we cannot have variables in the denominator. Okay, so 1 over n squared, that is a problem. Okay, the second rule, we cannot have variables underneath a square root. We cannot have variables with negative exponents. And we cannot have any other operation outside of multiplication. So 2c plus 7 is not one term anymore. Remember, mono means one. I now have two separate terms here because of addition. Okay. Constants are monomials with no variables. So that means a constant is simply a number. Coefficients are the numerical value of a monomial. So if you have a monomial that is 5x, that means the coefficient is 5. So we're going to name the coefficients of the monomials here on the bottom. Okay, so in the first example, my coefficient is -7. Okay, we're looking for the numerical value in front of our monomial. Okay, in our second example, the coefficient is 2. In example number 3, I do not see a numerical value in front of my coefficient. So I have to know there is an implied 1 anytime a number is not listed. So the coefficient on example 3 is 1. When we're naming the coefficient of a monomial, there can only be one per monomial. So example number 4 is one monomial, and since it is using multiplication, I have to multiply the two values that are there to get a coefficient of 8. So now we can move into our rules. Okay, so rule number 1 for exponents. When we multiply monomials, we add the exponents. Okay, that is your rule. Anytime you have coefficients, those are normal numbers, so we treat them with normal operations. So in example 1, I'm going to add the exponents. X to the 5th times x to the 7th is x to the 12th. Okay. In example 2, we are adding the exponents for like variables. So I can only add together the exponents of w together, x together, and now y's, what exponent should be implied on this first y if nothing is there? It's a 1. Okay. Now, example 3, it's still multiplication. It's just being represented using parentheses. Okay, and I see that there are coefficients. So I'm going to multiply the coefficients because those are regular numbers, so we're using regular operations, and then I'm adding together the exponents on like variables. So x to the 16th, t to the 4th. Okay? Simple enough. When you multiply, you add the exponents. So, when we raise a term with an exponent to another power, we're going to raise each term individually. So for the coefficients, that means we're going to raise the coefficient to that power. For the exponents, it means we're going to multiply them. Okay, so I'm distributing this exponent in, okay, but since it's an exponent, it's just going to work a little bit differently. So coefficients get raised to the power, and variables get multiplied. So in order to solve this, we're now just going to evaluate. Okay, so we don't want to leave it like this. So we're going to do 2 to the 8th. So in your calculator, just as a note, you're using that little caret button in order to evaluate. Okay, so that equals 256. So this is really, multiplying 2 by itself 8 times. Okay, and then everything else we're just going to multiply normally. So x to the 32, r to the 56. Okay, so that is called power to a power. So when you are raising exponents to another exponent, we multiply them together. Okay, so if when we multiply monomials, we add them, what do you think should happen when we divide? We're going to subtract. Okay, and I want to add a little star to this rule. Okay. We're always going to subtract the bigger exponent from the larger. Or I'm sorry, subtract the bigger minus the smaller. Okay, and what I mean, we're going to go to, you see how we have exponents in the numerator and the denominator? So wherever the larger one is, you're going to go to that, and that's where your final answer will stay. So it could be in the top, it could be in the bottom. And the reason that we're doing that is to avoid negative exponents, because we saw in one of the very first slides that we cannot have negative exponents in monomials. Okay, so the first example here, I'm dividing these. The larger exponent is in the numerator, so that's the order that I wanted to subtract in. Okay, I'm doing 17 minus 12 so that I get a positive. Now 17 is in the top, so my answer is going to be in the top. Now you don't need the 1, I was just doing it to make a point. So we can just leave it as x to the 5th. Okay, because in example 6, my variables are all over the place, and there's multiple of them. Okay, so the coefficients, remember, are normal numbers, so we're going to do normal operations. That means that we're going to divide or reduce our coefficients here. So 12 over 3 is 4 over 1. You do not have to put the 1, just showing you. All right, and then my variables, I'm going to go to the larger one. So for x, the larger one is on the bottom. So I'm going to do 9 minus 5, and x to the 4th is going to remain on the bottom. The y's have the larger one on the top. And remember, this is implied as a 1. So 2 minus 1, your answer should remain on the top. And the same thing for z. 10 minus 5 on the top. Okay, it's not a bad idea to circle the larger exponent for each variable so that you remember where it goes. So that is dividing. Okay, so similar to power to a power, this is now power of a quotient or power of a fraction. So we distributed this exponent outside the parentheses in last time. Okay, we raised the coefficient to the power and then we multiplied the exponents. We're doing the same thing here when it's a quotient or a fraction. We're also now just distributing to the denominator as well. Okay, so it's 2 to the 5th and 2 times 5 and k times 5 times 5. So this is 32 x to the 10 over k to the 25. Final answer. So power of a quotient. Okay, this is the easiest rule. Anything raised to the power of 0 is equal to 1. Okay, so x to the 0, 5 to the 0, 3x to the 4th, y, this is power to a power. It's all in parentheses. So that means that the 0 is applying to everything in there. That equals 1. Even this whole gigantic expression, because it is in parentheses, everything here equals 1. Okay, but be careful. It is only the expression that the 0 power is touching. Okay, so there's a difference between the expressions that are written here and perhaps something like this. Okay, only part of this expression, only this part is equal to 1 because that's the only thing that the 0 is touching. Okay, see how it is nothing to do with the power to a power of x squared to the 2nd power? So just be mindful of how the problem is written. All right, and our last rule, this has to do with negatives. So when we were subtracting, we did our best not to create negative numbers, okay? But sometimes it's unavoidable. Sometimes that's just how the problem starts off. So we need a way to deal with it. Okay, so all negative exponents must be made positive. So the way that we do that is either moving them to the top of a fraction or move them to the bottom of the fraction. Moving them between the numerator and the denominator changes the signs. They become positive or negative as you flip their spots. If something is not written as a fraction, you can put it over 1 and then make your change. So we'll take a look at some examples of that. So we see example 8 here, not written as a fraction, And you need to move your expression from the numerator to the denominator in order to change the sign. So I'm going to put this over 1. Okay, and now I like to circle the negative exponent because that's the only thing you can move. And you'll see in a minute when we put all of these rules together that you're going to have other terms in there. So you can't move the entire problem. All right, but for this, x to the negative 5, we're going to move it to the bottom, and it's going to become positive. Okay, so what is remaining in the top when we do that? It's just a 1. And the same thing now in example 9. I have y to the negative 7th in the bottom. If I bring it up to the top, okay, I can change it to a positive exponent. So I know that example 8 now breaks the rule of having exponents in the denominator, okay? But that is a lesser rule break than a negative exponent, okay? So if we have to make the choice, we want to have all of our exponents be positive, and if I have to have something in the denominator, then we're just going to have to accept that. All right, so we're going to put all of our rules together now. Okay, so think of order of operations, okay, when we're evaluating these. And the first thing that we would do is parentheses. Okay, well, they're both in parentheses. And inside the parentheses, there doesn't seem to be anything that I can do. Okay, now the second one has an exponent. So we're going to deal with that first. So remember, this rule was called power to a power. And you have the exponent on the outside of a parenthesis. So that means we're going to distribute this in. Coefficients get raised and exponents get multiplied. So that is m squared and n squared because they originally started with an exponent of 1. And I can evaluate negative 5 to the second power. When you plug that into your calculator, make sure you use exponents just like I have it written. All right, so now we're going to multiply the two parentheses together. So coefficients get multiplied, and like variables have their exponents added together. Okay, now I know that the first n has a negative, but when we add them together, I get n to the 0. And remember, anything to the 0 exponent just equals 1. So that's really times 1. So my final answer is 75 m to the 6th. Okay. In my next example, I see that I have parentheses with power to a power. So that seems to be the first thing that I do when I'm encountering these all-together problems. So I'm going to take my exponent and I'm going to distribute it in. Now, be careful on the top. That's really a negative 1, so that's a coefficient that also has to get raised to that power. And that 3 is not going to the denominator because the whole fraction is not in parentheses. The top and the bottom are each in their own set. Okay. On the bottom, I see an exponent of negative 2. Okay, now I know we can't have negative exponents, but the easiest thing for us to do is first take care of power to a power, and then move any negative exponents. Okay, so these two terms now are negative, so they're going to both move to the top. And remember, when you move them to the top, the only thing you change is the sign of the exponent. So now there's nothing in the denominator, so I don't even need the fraction bar anymore. And I can evaluate. -1 to the third power is -1. 2 squared is 4. And now I can multiply everything together. So -1 times 4, and I'm going to add my exponents. Okay, now you can choose to do things, in a different order towards the middle of the problem. If you wanted to add the exponents together before you did the coefficients, you could do that. Okay, but definitely the first step has to be the power to a power, because you can't do anything until you take care of the parentheses. Let's keep going. Okay, so example 12, this looks like a simple division of monomials. So I'm going to reduce my coefficients. I get 2 over 1, right? 8 divided by 4, so I'm just going to put a 2 on the top. And now I'm subtracting my exponents. I'm going to circle the bigger one for each pair. So I have m squared on the top, 3 minus 1, with n to the first on the bottom, 3 minus 2. Okay, and that's the only thing I can do there. So that is my final answer. All right, the next example, why don't you pause your video and try and simplify this one on your own before checking your answer. Okay, so I'm first going to do power to a power. So this is 9 m to the 4th n squared. And I'm going to multiply on the top. So 18 m to the 5th n to the 4th. And now I'm ready to divide. So divide or reduce my coefficients. So what goes into both 18 and 12? Because they're not going to divide evenly. But I can reduce them both by 6. So 3 over 2. And then subtract my like term variables. So 5 minus 3 makes an m squared on the top, and 4 minus 1 makes an n cubed on top. Okay, so that's my final answer. So did you get the same thing? If not, you want to make sure you correct your work and write down some questions next to this example. Okay, let's do one more. All right, this has a lot going on. So in the numerator, I have 2 sets of parentheses, okay, but there's no power to a power. So I'm going to go ahead and multiply them together, okay? Even though I have negative exponents, I'm going to take care of that in the coming steps. So I have 15 x to the negative 1st, y to the negative 5th. So multiply the coefficients and add the exponents. Just be careful of your signs. Okay, in the denominator, I'm going to do that power to a power. X to the negative 12th, y to the negative 2. All right, I'm now going to take care of my negatives. All right, there's not really anything else I can do on the top or the bottom until that happens. So the only thing you can move are the terms with negative exponents. So you see 15 has no negative exponent. So that is going to stay where it is. Okay, but x to the 12th and y squared come up to the top. X to the 1st and y to the 5th are in the bottom. Okay, and now we're going to subtract. So go to the bigger for each variable. So 12 and 5. Okay, so it's going to be x to the 11th in the top and y to the 3rd in the bottom. Okay, and that is your final answer. So I know there are a lot of exponent rules going on here. There's so many things happening in each problem. So we are going to spend a lot of time reviewing these. All right, you just want to make sure right now that you have down what all of your rules are and you understand how to apply each one individually. Okay, so if the putting it all together problems are causing you a little bit of stress right now, please don't worry. I just want you to work on each rule individual. All right, so that is everything for 6.1. Thank you so much for watching, guys. I will see you next time.